Okay, so here is the second page. Okay, this one has all of our limits of algebraic. Holy crap, what's going on here? Okay, so here is one of your strategies is to multiply everything out. Okay, notice how we have all these parentheses. Let's multiply them all out. So let's start with this, x plus h quantity squared. Remember that means x plus h times x plus h. It means multiply it by itself. Okay, so this gives us an x squared plus 2xh's plus h squared. Okay, when I do my distribution and my combining of like terms, that's what I get. And I still have a 3 out there in front. Okay, all I've done is the x plus h squared. Okay, now let's move over and let's do this one. So now I'm going to distribute my minus 4 into both of these. Minus 4x minus 4h. And then lastly, I'm going to distribute my minus. I am subtracting both of these terms, which means I'm going to distribute my negative into both of those terms. So this is a minus 3x squared and a plus 4x. So minus 3x squared plus 4x. Okay? And we're leaving our h alone, right? We haven't done anything with our h in the denominator yet. Okay, so let's do this down here. Limit as h approaches 0. Okay, now I'm going to distribute my red stuff. So I have 3x squared. And I have 6 xh's. And I have 3 h squareds. Okay, and now I still have my minus 4x minus 4h because I haven't done anything with that yet. And I still have my minus 3x and my plus 4x, sorry, minus 3x squared. Minus 3x squared and a plus 4x all divided by h. Okay, right, one algebraic step at a time, or we can easily get lost everywhere. Okay, one algebraic step at a time. Now that I have all of my terms distributed out, right, no more parentheses, no more separation, I can start combining my like terms. So this 3x squared subtracts this 3x squared. This minus 4x adds to this positive 4x. And then I have 6xh, 3h squared, and minus 4h. So that's what's left as my numerator. Okay, let me see if I have 6xh plus 3h squared minus 4h. Okay, that's what's left in my numerator. Notice all of these terms have an h in common, right? They all have an h. There are 3 terms in my numerator that have h's, and there's 1 term in my denominator that have h's. So what we're going to do mathematically is factor out 1h from each of these terms. Okay, since each of the terms on top have an h, we're going to factor that h out so that I can divide it with my h in the denominator. Okay, so I have the limit as h approaches 0 of 6x plus 3h squared minus 4. Right? No longer do I have a 0 in the denominator. I no longer have something that's undefined. So now, when h is 0, my answer simplifies to 6x minus 4. Okay, so I have an x and an h in my problem to begin with, which means my answer is going to have an x to end with. The h will be gone, and you'll have an x as your answer. Okay, our next one with these radicals, anytime you see radicals, you need to think about the word conjugate. Okay, a conjugate is how you do distribution and get rid of radicals. So if you want to call delta x p or something, I don't know, whatever you want to change it to, that's fine, but I'm going to leave it as delta x. So the conjugate is the same exact radicals with one change in sign. So I'm going to multiply the top and the bottom by 7x plus delta x plus 1, that's my first radical, plus root 7x plus 1. I'm going to multiply top and bottom by that same thing, 7x plus delta x plus 1 plus 7x plus 1. Okay, so we very could change delta x to an h, right? The change in x, we can make it any variable that we want to other than x. Okay, so here's the first thing. We multiply the top and the bottom by the conjugate. Okay, making sure that your sign of your product is different than the sign that we get there. Okay, because what happens is in the numerator, when I distribute, all of my radicals go away. Right, so root this times root that is 7x plus delta x plus 1. Okay, the radical goes away. And when we do these two, we get opposites. So we get a positive radical, and then we have a negative radical. So we don't even have to, quote unquote, do those ones. Those ones always subtract off, and we don't have a term with radicals anymore. Okay? We don't need to do those ones. But we do need to do our last one. Negative radical times a positive radical is minus 7x plus 1. Okay, and then on the bottom, yes, we have the same thing, delta x with these two crazy radicals. Okay, and to save time, I'm not going to rewrite them. So now let's look at this purple stuff. Okay, we're going to get rid of our parentheses and change this into a quote-unquote simplified equation. Okay, so I have 7x plus 7 delta x plus 1. Right, so I'm just distributing into my parentheses. And then I have to distribute my parentheses. So minus 7x and a minus 1. Right, all over delta x times my two crazy radicals. So now I'm looking at my numerator. What things in my numerator can I cancel? 7x with the 7x, 1 with the 1. Okay, and then what else can I divide out? The delta x with the delta x. Okay, these problems are designed so that this happens all the time, right? This is supposed to happen, right? We're not supposed to have delta x in our problem anymore. So we have a 7 in the numerator, and I have this crazy radical, 7x plus delta x plus 1 plus root 7x plus 1. At which point I'm going to plug in delta x for 0. Okay, so all that does is that changes my denominator of the first round. The 0 just goes there. So let's see, what do I have in my numerator? I have the number 7. And what do I have in my denominator? Well, I have one radical of 7x plus 1, and I have another radical of 7x plus 1. So how many radicals do I have total? 2 radicals of 7x plus 1. Okay, so we don't ever do anything with this radical 7x plus 1. That just stays there in our problem with a positive 7 on top. So this will be the end of our second video. We'll finish up the rest of these problems later, and we will hopefully be good to go for our test coming up.